In this problem, we're given a list of n numbers that is created using some operation. This operation is given any number, you can divide the number by 3 if that number mod 3 is 0, or you can times that number by 2. And this list you're given can be in any order. What you want to output is in the right order such that these operations make sense. So if you look at this example, so 9 over 3 is 3, 3 times 2 is 6, 6 times 2 is 12, 12 over 3 is 4, 4 times 2 is 8. So the first thing you have to observe is that every number, let's call it x, can be written as 2 to the power of x times 3 to the power of y times some extra, in which this extra portion is informed by the primes 2 and 3. So now that we have this, we realize if we divide a number by 3, then y goes down, and in our operations we can never increase y. So what this means is that any number with a higher y has to go to the left of any number. By that I mean has to occur first than any number that has a y that's less. So that's the first thing. Now the next thing is, okay, so we know the order if a y is bigger than or less than, but what if they're equal? So let's take a look at this case, right? So this is the actual answer. Now let's look at the y's here. This is 3 to the 2, right? This is 3 to the 1. Yes, this is 3 to the 1 times 2. This is 3 to the 1 times 2 squared. This is 3 to the 0 times 2 squared, and 3 to the 0 times 2 cubed. Right? So this is in order of highest y to lowest y. Now look at these two numbers. If they're equal, what do we do? Then it makes sense that if they're equal, the number that's larger should go on the right and should occur after, because the only operation we have is times 2, and therefore the smaller number has to occur first. So now that we know how to tackle the problem, let's do it. So we're given an integer n, and let's save these in a set of pair of integer and long. And it's a long because the largest value of a can go all the way up till 3 times 10 to the power of 18. So what this will store is this will store the y value and the integer itself. And by the y value, it basically how many times can 3 divide into this number until it stops being able to, until the number is 0, or you can't divide this number anymore. Oh, sorry, not 0, 1. So now that we have this, we can just, so we get our number, and then we just say, let's count the y value, right, which is initially at 0. So while x mod 3 is 0, we can increase our value. Oh, let's do that. We can increase our y value, and we have to divide x by 3. And then in the end, we insert the y value and x. But here, since we change x, we have to save x. So let's just call it OGX. Oops. And here we'll just int the original x is equal to x. So here when we change x, it won't actually change the original value. Okay, so now that we have these all in a list, we want to output them. But first and foremost, we want to sort it in descending order. So just if we make this negative, then for a y value of 3, this value would be minus 3, and then that would occur first in the set because the set is ordered. So that makes sense. So now we just iterate through the entire set. So we do auto, we're going to just y in this set, and then we would just output the integer that we want, and that should work. Oh, didn't. Yep, that should work. 9361248, perfect. Oh. It's a long, so our x itself, that they should be longs. Y value has to be an integer. Okay, everything now works. So output, yep, that's the right order. Submit. And voila,